Okay, so recently I've been working on some home projects, and this most recent project needed a drive shaft. I had a short deadline for the project, and the project would include a pillow block bearing. I went online to browse for a pillow block and quickly discovered that in addition to being a little expensive for this project's budget, I would also be delayed a whole week with the delivery time. With my preferred deadline closing in, I decided I would try to make my own bearing. That way I could continue the project and have some fun along the way. Normally, when I'm designing my projects, I restrict myself to regular sizes of hardware. That way I can keep reusing the same parts in my project while not having to spend extra money on keeping different sizes. With this new idea of printing my own bearings, I wanted to try to make a customizable part that I could resize for projects in the future. With this new bearing, I had 3 goals. 1, I wanted a pillow block bearing that could be resized for any shaft size in less than 10 minutes. 2, the parts should be optimized to be compact while still being easily customizable. This would keep the volume of material down and allow me to make the pillow block bearing for less than $5. 3, the parts need to be in a way that I could increase the thickness and therefore the strength to match the demand of future projects. I chose to model my bearing in Inventor because that's what I have available to me, and that's the modeling program I've spent the most time in. So the first part is setting up the parameters. I wanted to make the resizing part very simple, where all I need to do is resize this list of parameters in each part and simply export the file to my printing software. After planning, I landed on these 5 main parameters for the project: length, width, height, bearing OD, and untapped hole OD. At first, as I dimensioned the parts, I used any parameter that would fit the distance I wanted for that particular dimension. But when I went to test rescaling the part, all the features would move around relative to each other, and I soon realized that I would need to use a parameter that shared the same axis as the direction of the dimension I was using. During my first design, I originally used 3D printed bolts. I experimented with different printed diameters and thread sizes, but found that even if I printed thick bolts, the plastic bolts would elongate and slip off the thread. I tried coarse, fine, and metric threads, but looking at the upcoming project, I knew this wasn't going to cut it for me. I think that it could have been fixed if I changed to a beefier thread standard like Acme, for example. That thread type would give the design more room for the threads to strain without fully slipping past the thread. But this was already taking too long, so I decided to switch to adding metal fasteners instead. These are very common and can be picked up in large quantities. If I scaled the size of the bearing to a heavier size, I may need to resize this in the future, but for now, I'm happy with how it turned out. Now for the printing part. When printing these bearings, I wanted to reduce the amount of support needed, so I went ahead and added some custom supports in the pinholes. These help the pinhole to print accurately. With the custom support, I can just reach into the hole and cut the custom support out with pliers. It's also better to print the part in 2 pieces so that the bearing face is on the top of the print to ensure it prints accurately with a smooth surface.
Here is a clip of how I organized the bearing in the printing slicer. As I scroll between the part layers, you can see the gyro infill layer going down. I never get tired of seeing that. Enjoy a short time lapse as the bottom and top parts are printing in the 3D printer.
For the assembly stage, I made it so that you could size the bearing to allow for a ball bearing to sit inside the bearing OD, or you could just allow the drive shaft to rest on the bearing face and slide across the low friction surface. For projects requiring high RPMs, I'm gonna need to always use a ball bearing to avoid having to replace the pillow block, but for low RPM projects similar to the one that I'm working on, just allowing the shaft to rest on the bearing face should work just fine. For me, these bearings turned out great. I'm happy with how fast they print and how quick I can design them. I'm also happy with the cost that it takes to make them. Now, if I have any projects in the future that I need a bearing, instead of ordering it online, all I have to do is just print it up. The step files are gonna be put in the description for this video, and let me know if anybody has any comments on the design or used it for themselves and tried it out.